This video presents dynamically reconfigurable PV systems for exhibition at University Booth Design Automation Conference 2013, Austin. This is a collaborative work between CAD4X Group in Seoul National University and Sport Lab in USC.
Photovoltaic or PV systems have been widely deployed for many applications such as PV power stations, solar-powered vehicles, and heating and lighting appliances. A PV module in the system is comprised of a number of series parallel connected PV cells. Each PV cell has a maximum power point MPP under a certain solar irradiance level. If the PV module receives uniform solar irradiance, all the PV cells can operate at their MPP simultaneously, and we can achieve the maximum output power of the PV system. However, PV systems are subject to the partial shading effect and PV cell faults. Partial shading makes the non-shaded PV cells that are series connected to the shaded ones also deviate from their MPPs. In this case, all the PV cells in the system cannot operate at their MPP simultaneously, and this results in a significant degradation in the PV system output power. PV cell faults will have the similar effect, and they may lead to hotspots or even more PV cell faults due to reverse biasing. For PV system fault detection and tolerance, we can select a subset of PV cells in the system and test their output power based on this reconfiguration architecture. We also propose fault detection and tolerance algorithms that effectively detect and bypass the faulty PV cells.
We perform reconfiguration of PV array using the following switch topology. Each PV cell is integrated with 3 switches, that is, a series switch and 2 parallel switches. These switches allow changing series parallel connection topology of a PV array. All 3 PV cells are connected in parallel. We change the connection to 3 PV cells connected in series. We could also configure the switches to have imbalanced topology. 2 PV cells are connected in parallel, one is connected in series. The PV cells operate in different voltage and current.
We have implemented the first version of the PV reconfiguration board by hand.
Here is a complete PV reconfiguration switchboard. This is a main controller of this reconfiguration switchboard. And these are MOSFET switches. And these are MOSFET driver chips. IPA 030N MOSFET switches deliver up to 30 ampere currents and 60 volts, and HT0440 driver chips provide complete isolation of the logic signals and the power path. The board is capable of managing PV array of 14 cells and has expansion ports for large PV array. The control part here and routing part here are electrically isolated to ensure reliable operation. There is CAN interface for controlling the switches.
Please come to see our demonstration of dynamically reconfigurable PV systems. It is scheduled from June 3rd to June 6th, 2013 at